Okay. And then the question 2, let's yxt denotes the displacement of a vibrating string. If t is the tension of the string, okay, omega is the weight per unit length and g is acceleration due to gravity, then y satisfy the equations del 2y del t2 equal to, okay, t, okay, is the tensions, okay, in the string, g is the, okay, gravity. Where they put so they use your unit, not the, okay, SI unit, they use 32 feet, okay, per seconds squared. This is a, okay, gravity force. And then x from 0 to 6 where the t is positive. Suppose, okay, a particular string is 6 feet long, that's why, okay, x from 0 to 6 and is fixed at both ends, taking t equal to 32 pounds. Okay, so the t, okay, substitute 32 pounds, okay, omega is 0.01 pounds, okay, per foot, and g is 32 feet, okay, per second squared. Use a finite different method to solve y up to level 2 only. The initial conditions are, okay, this is the first initial condition, okay, mean initial condition happen when t equal to 0, because y is a function of x and t. So when t is 0, okay, the function is x over 6, where the x from 0 to 3, when x from 3 to 6, the function is 6 minus x, okay, 6 minus x, okay, divided by 6, and del y del t, okay, x0 equal to x times x minus 6. Okay, perform all calculation with delta x equal to 1 feet and delta t equal to 0.01 seconds. Okay, may I know, okay, question 2, this one is ODE or PDE? Okay, I would like to call somebody. Okay, Angeline. Okay, Angeline, are you around?
Yes, doctor.
This question, ODE or PDE? Question 2A here. Is it ODE or PDE? First question. You can also type, okay, in the chat, okay? Okay, those want to answer also, you can type in the chat ODE or PDE.
PDE.
PDE, correct. Okay, thank you. And then, okay, PDE because y is a function of x and t. So when you have a function more than one variable, you can differentiate y respect to x, you can differentiate y respect to t. So this is a partial differential equation, PDE. Okay, and then Chris, okay, so PDE, we have 4 type: heat, wave, Laplace, Poisson. So this one is which equations?
Wave.
Yeah, correct. Thank you. Okay, cos, okay, wave equations. You have both, okay, the time derivative and the, okay, spatial, okay, derivative, mean the x here. Both are second, okay, up to second order. So this is a wave equation. Okay, and so normally we use u, but this question they change the u to y. So this is similar to your wave equation del 2u del t2 equal to, okay, so mean in this case the c squared is actually t times g divided by omega. So, okay, normally, okay, the wave equation that we, okay, we learn, we stand in this form. Okay, you learn the wave is del 2u del t2 equal to c squared del 2u del x2. Okay, this question they just change the u to y, and then c squared in this case is given by the tension times the gravity force divided by the weight per unit length. And they are not using the SI unit. They already asked 1 feet, so you just substitute the c squared is actually the t 32 pound times the g is 32 feet per second squared. Now divide by the omega is 0.01. So this is a wave, and then this one, the del u del y del t is not 0. So this one, because this set no marking scheme, that's why I pick this set. So I'm going to do is we go to as I think and your c squared in this case is actually what's a t given t g omega. I put w. T is 32 pound. T 32 pound. G also 32. W is omega is 0.01. To check whether their unit. Let's say calculate c squared. Is a t 32 pound. G 32 feet per second squared, divide by omega is 0.01 pound per foot. Pound cancel, so the c squared here foot per second squared. My 0.01. Hold on. So this one 0.01. The c squared, we go to calculate 32 times 32 divide 0.01. Very big. So whether the unit never mind, we try the c squared in this case 1024 32 times 32 divide 0.01. And then let's say the hk and the k. H is a delta x is 1 feet. H is 1. K is a delta t, which is 0.01 up to level 2. Is 0.01. And then you need to find the for wave equation, you need to find that rho squared. Rho squared. Can you say remember what is the where's the rho squared? Where's the formula there? If not, you look. They will give you the wave equation by the finite difference method. This is a formula. The rho squared is actually your k squared bring to right hand side is a k squared c squared over h squared. Mean the k squared collect to right hand side, you have a k squared c squared over h squared, that we denote it as a rho squared. So it's a k squared, this one k squared, and then time, this is c squared divided by h squared. Okay, and then okay, can you still remember in the wave equation? Okay, after you get this one, what is k, the three level molecule? Okay, if you cannot remember that three level molecule, then you have to derive again. Means the wave equation you have is, okay, del 2, this case is del 2y, okay, del t2 equal to, okay, we put it c squared del 2y del x squared. Okay, del 2y del t2, okay, using 3-point centra. Okay, you will have this is y, differentiate respect to t, where the x is discretized using I, y is discretized using j. So you have this is a y, the yi plus 1, sorry, yi. This is yij plus 1 minus 2 yij plus, this is yij minus 1 divided by, this is a k squared, and then equal to, okay, this is, okay, c squared, differentiate respect, this one differentiate respect to x, where the, okay, where the y is constant. That's why you have, okay, y, this is a I minus 1, this is j minus 2 yij plus yi plus 1j divided by h squared. Okay, if you cannot, okay, forgot, okay, that three level molecule, okay, to solve for level 2 onward, okay, what is the molecule, okay, coefficient, then you have, okay, from the formula given here, the formula given here, okay, you have to, okay, to obtain that three level scheme back, then you have, collect your k, bring the k squared to right hand side, you have yi j plus 1 minus 2 yij plus, this is yij minus 1 equal to k squared c squared over h squared. This is yi minus 1 j minus 2 yij plus yi plus 1j. Okay, so where this one is what we denote as a rho squared. Rho squared yi minus 1 j minus 2 yij plus yi plus 1j. Okay, and then we're collecting, okay, you have the level j plus 1. Okay, this is level j minus 1. Okay, this one level j, okay, and this term collect together. Okay, and then yij minus 1 bring to left hand, right hand side. That's why you obtain your three level scheme yij plus 1. This is a top level. Okay, equal to, you have the rho squared. So yi minus 1 j. So plus minus 2 here, bring to right hand side, you have 2. So okay, this is minus 2 rho squared. So 2 minus 2 rho squared yij plus rho squared yi plus 1j. Okay, and this term level j minus 1 bring to right hand side, you have yij minus 1. Okay, mean if you forgot, okay, what's the coefficient, then you have to derive again. Then from here you will, okay, you can draw that, okay, this one is 1 time yij plus 1 equal to, okay, middle is, this is 2 minus 2 rho squared. Okay, this is yij. Okay, right is rho squared yi plus 1j. Left is rho squared yi minus 1j. Okay, and the bottom level, you have actually, okay, minus 1 yij minus 1. Okay, this one is for level 2 onward. Okay, because, okay, yij minus 1, this represent the initial condition, which is, okay, level 0. Then you need, okay, to find level 1 in order you can find level 2 onward. Okay, for level 1, we'll eliminate yij minus 1 using, okay, the second initial condition. Where your second initial conditions is here. Del y del t, when t equal to 0 is equal to x minus, okay, 6. Where this one, Control C. Yeah, cannot copy. Copy. Nothing. So x minus 6. You have a del y del t. Okay, this is a x 0, mean when t0 is equal to x minus 6. X minus 6. Okay, and then for del y del t, this is the first derivative. Okay, differentiate first derivative respect to t. You can have, in general, you have actually is y, differentiate respect to t. Okay, x is constant, that's why you have yi. Okay, let's say j, so j minus 1, this is j plus 1. Okay, this is at the point xi, that's why yi, you have j plus 1 minus yi j minus 1 divided by 2k equal to, okay, let's say this what we denote as a gx. So the yi j minus 1, okay, you got here yij plus 1 minus yij minus 1, mean take top minus bottom, equal to 2k gxi. X discrete type using I variable. So you want to eliminate yij minus 1 here. You want to eliminate this one, yij minus 1, to get two level scheme to solve for level 1. So that's why yij minus 1 equal to yij plus 1 minus 2k gxi. Okay, so that's why we plug in here this thing here to here. So you get I put up here, you have a yij plus 1 equal to, okay, rho squared yi minus 1j plus 2 minus 2 rho squared yij plus rho squared yi plus 1j. Okay, so minus this thing here yij plus 1 minus 2kg xi. So this one, okay, this term and this term, okay, you collect, okay, total we have 2 times 2 times 2 times yi j plus 1 equal to rho squared yi minus 1j plus 2 minus 2 rho squared yij plus rho squared yi plus 1j. So minus minus become positive 2kg xi. Okay, so we want one time of yi plus 1, yij plus 1. So it will be 1 yij plus 1. Okay, you want one time, so right hand side divided by 2. That's why I have rho squared divided by 2 yi minus 1 j plus they become 1 minus, okay, rho squared yi j plus rho squared divided by 2 yi plus 1j plus kg xi. Okay, and then so that, and this one is actually because, okay, the del y del t happen when t equal to, okay, 0. T equal to 0 is actually j equal to 0. And when t equal to 0, j equal to 0. So that's why, okay, here this one is actually for yi, okay, j0. So it's for level 1 only. Rho squared over 2 yi minus 1. Okay, j is 0. Mean, okay, j0 is an initial, okay, condition. Level j0 you can obtain level 1 plus 1 minus rho squared yi0 plus rho squared over 2 yi plus 1 j, j is 0. J is 0. Then plus kg xi. Hence, k, this is k for level 1 only. Level 1 only. Yeah, one time yi1 equal to, you see, middle is 1 minus rho squared. Left, right is rho squared over 2. Okay, left is coefficient is rho squared over 2. Okay, this is u, here they use yi minus 1 0. This is yi 0. This is yi plus 1 0. Okay, and then you have, okay, another here. Okay, this is kg xi. So if you, okay, but since, okay, you are online, if you forgot, okay, you may just, okay, open back your notes. Okay, where is it? And this one is, okay, just now what I did is last time, let's say in exam hall you forgot, okay, the molecule, then you have to derive back, but you're lucky you're still online. Okay, then you may just, okay, open back the notes, okay, and see, okay, the molecule here. So this 3-level scheme for level 2 onward. So, okay, one time of the, okay, uij plus 1 j is actually, okay, starting from level 2 onward. Left, okay, molecule rho squared, center, okay, 2 minus 2 rho squared, right is rho squared, bottom is, okay, negative 1. And then where is it? Oh, and then for level 1, so one time ui1 equal to the left, okay, molecule, okay, coefficient is rho squared over 2, center 1 minus rho squared, okay, right is rho squared over 2, okay, plus k gxi. Okay, in this case gx is not 0, is equal to x minus x times x minus 6. Okay, so once you get the okay, you get the molecule, you may, okay, draw the specific molecule. This is general, and then you draw the specific molecule you have. This is one time. Rho squared. You calculate here. Rho squared cell C8. C8. This one is the rho squared. This cell is -1. 2 minus 2 rho squared equal to, I haven't calculated 2 minus 2 rho squared. 2 minus 2 rho squared. 2 minus 2 times, this is a rho squared. So this cell is F5. So this is the molecule for 3-level scheme used to calculate level 2 onward. When this for level greater and equal to 2. For level 1, you have here 1. Level 1, the exactly half of the middle level of your 3-level scheme. So this is rho squared over 2. This one also 1 minus rho squared is half of the center level of a 3-level scheme. So this one same thing. And then KGXI, K is 0.01. You may put the K you have here 0.01. GX is actually given X minus 6. Gx is a initial velocity x times x minus 6. Where the x value depend on the cell that you target. That's why you can put at the center here. Then we draw the grids. They want up to level 2, so 0.02, 0.01, 0. And the x 0 to 6 with increment 1 unit. Right. And then the initial conditions you have here. Initial conditions from x0 to 3 is given by the function x divided by 6. So this is the x divided by 6 up to 3. So 0.5. We see whether the second function here tally. So for 3 to 6 is given by 6 minus x. This one numerator 2 term, make sure you bracket it. So divide by 6. Overlap the value. And again you see the string is fixed at both ends. String is fixed at both ends. So Indrajit, are you around? Indrajit? Okay, Lim, Yu Qi, Lim, also not around. Lim, okay, okay,
Yes.
yeah. So the string is fixed at both ends. So what is the boundary condition for the wave equations? What is the okay, what are the boundary condition? Okay, when x0, x equal to 6, what is the value there? This value. What is the value here? The string is fixed at both ends. You see, the question only give you initial condition. So what is the boundary conditions? Okay, who know, please type it. Okay, what's the boundary conditions? Okay, for wave equations. Yuqi, okay, what's the boundary condition? Okay, who want to help? Muhammad Saman?
X0 equal to times.
Yes, 0. Okay, wave equations, okay, the boundary condition always 0 because fixed, it cannot move. Because okay, for wave equation, okay, in this case the y is actually displacement of the wave of the string. It's fixed, that's why it cannot move. That's why okay, both side must be 0. Okay, then you just need to calculate level 1 using this molecule here. Okay, level 1. So now I don't highlight, no fill, no fill. Okay, so now using level 1, okay, you need this one. Okay, sorry. So I will calculate, and then I will calculate here. Or you want to calculate, this one is x, gx here. Okay, gx is actually x multiply, the x is b43 minus 6. Okay, I calculate the gx below the x-axis. This is okay, x. Then this value is gx. Yeah. Okay, gx is okay orange color. Yeah, calculate gx at the okay below the x-axis. Okay, so now you want to okay calculate level 1 using the two level scheme like this. So this is a gx here. Mean the cell that you target is equal to 5.12 times the left okay cell okay in the grids, okay minus okay 9.224 times the okay center bottom cell in the grid plus okay 5.12 times the right bottom cell in the grids, okay, and then plus 0.01 times gx. Okay, gx already calculate below the x-axis. Okay, then you just put in, you have okay, you can may click this cell, then you need to constant it putting dollar front and back, or else you type in 5.12. Okay, time left bottom cell plus okay the okay center bottom okay coefficients multiply the center bottom cell plus the right okay bottom molecule, right bottom coefficient multiply right bottom okay cell in the grids, and then plus k is 0.01 times gx already calculate below the x-axis here. Okay, so you may okay round it to 4, and then you copy it. So this is level 1. So this level 2, this is level 1. Okay, this is level 0. Okay, level 0 initial condition, level 1 using the 2-level scheme, and then level 2 using this 3-level scheme. Okay, lastly, okay, to calculate level 2 onward, use the 3-level scheme, like here. So mean, okay, the cell that you target is actually equal to 10.24 multiply left bottom cell in the grids minus 18.48 times the center bottom cell in the grids plus 10.24 multiply the right bottom cell in the grids minus 1 time, okay, this one times 0.1667. Okay, and then you just key in. If you use the value in the molecule, make sure you constant it by putting dollar front and backs. Multiply the left bottom cell plus center bottom coefficients. Okay, multiply. Okay, multiply center bottom cell plus this one. Multiply the right bottom molecule. Okay, minus, okay, 1 time here. So you key in C40, your middle is all, okay, row 41. So this is B, C, D. Okay, and bottom, okay, level is 42. So correct. Okay, you want to round or don't round, also, okay, here 4 decimal place. Okay, so you completed the questions. Okay, this question 2a, the wave equations here. Because okay, there's no scheme to check. Huh? So any question, this one, the wave equations. So you can see skate question 2 consists wave, and then you have a heat equation. So this is solve the heat equation up to first level only, explicit finite difference method. So given the wave equation, given the heat equation, pi del u del t equal to 4 del 2u del x squared, x from 0 to 1, t is positive, with boundary condition u0 t equal to 0. Okay, I ask someone. Muhammad, okay, Muhammad Saman. Muhammad Nosarin. Muhammad Nosarin. Muhammad Haziq Aiman. Muhammad Zahiruddin. Navin. Nonisa. Okay, please respond it because it's recorded. When people watch back the YouTube, see you are sleeping. Nurul Iza. Celia. Sadesh. Okay, Tan Guo Zi. Tan. Okay, and then Tei Zijian. Okay, u0t equal to 0, is left, or right boundary?
Left, doctor.
Left. Okay, thank you. u0t is u0t equal to 0 is left. Tiba sini. Okay, also not. Okay, just take attendant and left. Okay, never mind. Okay, Vincent Teo also not around.
Yes, Doctor.
Vincent, U1T equal to T. This is left or right boundary condition?
Yes.
Left or right?
Left.
You see x 0 to 1. X equal to 0 compare x equal to 1. Okay, watch here. Because if you put the boundary condition you put wrongly, then it affects all the answer. This is x equal to 0. X equal to 1. So x equal to 0 compare x equal to 1. So the second conditions here, u1t. Okay, maybe some of you confused, left, right. So this is left. This is right. I think some of you confuse left, right. Some person also they confuse left hand, right hand. Initial condition is always you have a t equal to 0. Okay, so we try to solve this one quickly before the time's up. Okay, and you need okay, never mind. So Control C. Okay, against you see you have to arrange back the equation so that you can calculate your c squared. You have del u del t equal to, so pi bring to right hand side, so 4 over multiply bring to right hand side become divide. 4 over pi del 2u del x2. So okay, so the c squared is 4 divided by pi. Hence c squared is actually equal to 4 divide pi like this, pi. C squared is 4 divided by pi. H, okay, and then k. Okay. H is 0.2, k is 0.01. K is 0.01. Okay, and this is a heat equation. Okay, approximate at the point xi tj using the explicit finite difference method. Del u del t using 2-point forward. This is using 2-point forward. You got uij plus 1 minus uij over k. So del 2u del x2 using 3-point centra. Differentiate respect to x. That's why j is constant because at the point xi tj. So you have the left point ui minus 1j, center minus 2 uij, right is a ui plus 1j. Okay, it will give you like this. So you can put it here. And then if you cannot remember the coefficient of the molecule, then you have to again derive back to get that two level explicit is 2-level scheme only, this one. So you have uij plus 1 minus uij equal to kc squared over h squared. So this is what we denote as R. So ui minus 1 j minus 2 uij plus ui plus 1 j. Okay, where this one we denote as R. So you have R ui minus 1j minus 2R uij plus, don't forget R. Okay, R you expand in, so you have R ui plus 1j. So solving for uij plus 1, mean you're collecting this term and this one together. So uij plus 1 is r times ui minus 1j. Okay, so you have here minus, bring to right hand side, become positive 1. So 1 minus 2r uij plus r times ui plus 1j. Okay, that's why the molecule 1 time uij plus 1 equal to, okay, center, the coefficient will be 1 minus 2r. Okay, this is uij. Okay, right, okay, bottom cell is r times ui plus 1j. Left, okay, is r times ui minus 1j. Okay, so you can get your, okay, molecule, and then you calculate, go to calculate the r is actually kc squared. So r kc squared divide h squared. So k multiply, this is already c squared divide h power 2 h squared. Okay, and then you may draw your grids from where to where. Okay, okay. They want, okay, first level only, x0 to 1. Okay, one first level only. Okay, so here I got, and then this one, you may draw the specific. Okay, this is general molecule, the specific. Okay, here you can calculate 1 minus 2r is equal to 1 minus 2 times, this is the r. Okay, so this one is equal to this cell. Okay, r equal to the r here, equal r. Okay, so this is a specific K molecule. Center. Okay, they want level 1 only. So K is 0 0.01. So 0. Okay, x0 increment is 0 0.2. Okay, so up to 1. 0.6.81. So this is x. Okay, so you want the value here. Initial conditions given. Okay, what's the initial condition? Okay. Okay, initial condition is when t equal to 0, u is actually x times 1 minus x. So this is x multiply 1 minus x. Okay. Okay, and then just now u0t equal to 0. This is a left boundary. Left boundary here. Okay, left side equal to 0. And then u1 t equal to, okay, t. Yeah. Okay, u1 t mean when x equal to 1 for all the t, the u is equal to t. So here, okay, t0 is equal to 0. Okay, and then equal to t. So you just need to find the level 1 using, okay, explicit molecule like here. So the cell that you target is actually takes a coefficient from the molecule. Make sure you constant it. Okay, the left coefficient, left bottom coefficient multiply the left bottom cell plus center bottom coefficients. Okay, multiply the center bottom, okay, cell in the grids plus the right bottom coefficients. Make sure you constant it. Okay, otherwise you type, but you type the value, and then so 23 CD. So this is E23. We'll key in at D21. 21, 22. Let me check back. Okay. Okay, we'll key in D22 bottom 23 C D E. Okay, here C is left, D is center, E is right. We key in at the C D, column D, D22 bottom is row 23, so correct. So this is B, the BCD row 13, BCD, correct. Okay, then just drag it. So done. One question. Okay. How many questions? So okay, the we don't know. Okay, sometimes is maybe 4 questions, sometimes it's 5 questions. So we just managed to solve that question to the PDE, and then the rest you may have a try by yourself. This one I think similar with the question in the exercise 2 in the books. Second method you didn't learn, so you can change it to Newton's change it to bisection method. So do little, haven't asked in your test yet, so you may most possibility those that haven't asked in chapter 3 only ask Gauss eliminations and Gauss-Seidel, so maybe you can ask back Doolittle Thomas method. So this one Thomas algorithm you didn't learn, so then you can change it to Thomas method. Okay, Newton divided that they asked already, Lagrange also asked already, so high possibility maybe is a cubic spline. And the numerical differentiation integration that haven't asked in the test yet, so you have to study all the topic. Okay,